Hi, good morning everyone. I can't say this presentation is going to be as jovial as Dr. Michael's, but I'll give it my best shot. Yeah, I guess we didn't really know this at the time when we organised this meeting, but obviously today falls on the 5th anniversary of the Grenfell disaster, which is quite poignant, I guess, in terms of what we're going to be talking about for the next 20 minutes or so. So yeah, let's crack on. Okay, so really today is going to give you an overview in terms of how powder coatings contributes to fire. We'll deep dive into how it's formulated and how that affects its overall performance. We'll then look into what's actually tested, how it's tested, and we'll look at it not just from a small scale testing, we'll look at it from a larger scale testing as well. And we're not just going to look into powder in isolation, we'll be looking at competing aluminium finishes too and how they perform. And also to end on, we'll like to use a tail of the tape scenario in terms of the costings involved as well, which I'm sure there's a few people in this room would be interested to know. Yeah, just a quick one for those of you not aware, I'm the specification manager for AkzoNobel powder coatings, so a lot of my time is spent with our kind of indirect customers on that sort of pyramid, so I tend to get involved in early stages and kind of police it from a technical and material perspective. And without going too much into the corporate propaganda, which I could do, one quick slide on AkzoNobel. This is pretty much a full list of the brands that we own. Some of those may surprise you, particularly those on the right-hand side. At some point in your life, you've probably purchased an AkzoNobel product without knowing. But the focus of today will be Interpon in the middle. That's the powder coatings brand that we sell globally. Okay, right, so let's get into it. So yeah, 5 years on, lots happened, and had we done this presentation 5 years ago, this would have been a completely different narrative, but here we are. And I guess it's always useful to start with something like this, where had I been standing here 5 years ago, and we looked at this sort of elevation here, we probably thought that was okay 5 years ago. Whereas now, we look at that thinking, oh, okay. That's just not safe at all. So it's weird how the dynamics have changed very quickly, and rightly so. Obviously, a few years ago, big trend towards timbers, popped up almost everywhere, whereas now you're looking at it and thinking, yeah, that's a big risk. So in terms of what's happened, obviously there was a big review that happened in 2018, which was led by Dame Judith Hackett. And what came out of that was a lot of these sort of buildings were basically reviewed, and they found out that certain materials weren't compliant, and the main cause of that was ACM panels, which is obviously what was used in Grenfell. At the beginning, there's only 400 blocks, apartment blocks that were kind of set aside, but now as the years have gone on, that number has just grown and grown and grown, and also the level of materials that are also a big risk have also grown too. So now there's estimations anywhere close to 5,000, 6,000, 7,000 buildings which need to be recladded. So it's growing over time. The regs are changing over time as well. So for a long time it was over 18 meters. There was an update recently whereby buildings between 11 to 18 meters are now going to outlaw a lot of those materials that you see there, unless it basically meets and passes a large-scale cladding test. So it's going in the right direction. It's taken a while for it to get there. But I guess similar to the King's Cross fires that happened 30 years ago, it took a while for the rail industry to be where they are now. So we're very much in that pathway. I guess what we've seen in the marketplace is a huge amount of, I won't say paranoia is a word, but it's almost paranoia in the sense that people want to adopt the risk-free belt and braces approach. And that has increased the clamour for the A1 rated materials. And we'll go into why that's not necessarily required as we progress. And yeah, insurance has gone up tenfold over the last 3-4 years. Very difficult to get PI cover now for cladding. And those costs are not really going to sort of level off anytime soon. So there's all these things that are kind of boiling away in the pot, so to speak. Okay, so this is the bit where we'll start getting involved in terms of how actually powder kind of contributes in terms of the grand scheme of things. So I thought I'd start off with this because this is an interesting summary, just to give people a visual understanding of where everything sits. So we've got like a league table here, almost, of all the kind of classifications that you can get within the main testing which is this EN13501. So that's embedded within Part B regulations, okay? And before Grenfell, a lot of those could have been used, okay? Whereas now, only two of those classifications are permissible for buildings over 18 meters, and that's the top two that you see there. So you can see when you put it in the context of all these other classifications, there's a reason why the government only allows those two. But as I say, people want to take it to the nth degree and go for the top one when in actual reality there's no need. So essentially what you've got here is three sections. So you've got a section which looks at the combustibility, which is the A rating, all the way to F. You've got smoke production, which sits in the middle, and then you've got the flaming droplets. So those are the three key criteria which we're going to focus on. Right, so this is the testing and what it actually looks like when you break it down. Okay, so it comprises of 4 individual tests, and what it does, it tries to classify. Well, it basically classifies the fire performance of any given material. And it's also important in determining how that material contributes to fire, particularly in the early stages when it's quite crucial to the safe evacuation of a building. So if we take these 4 tests individually, you've essentially got what they call a single burn test here, which is essentially panels formed into a right angle. It tries to replicate a corner of a room. It takes place in like a chamber. Propane gas is lit. There's a hood at the top, and that's measuring, essentially collects all the smoke production, the heat release, but it also looks at whether the flame is spreading and also whether there's any flaming droplets as well. So that takes place in a much bigger chamber. The second test, ignitability, that's a much smaller chamber, much smaller panel. That essentially looks to see how fast that flame kind of spreads vertically. You've got some filter paper at the bottom to see whether there's any falling debris. And that's essentially, I think it's 150 millimeters to the top, and they see how quickly that races up there. So those two are looking at coated aluminium. The third one along, that's essentially where you get cured aluminium profile, and you scrape off the coated film, and you put that into a small crucible, and that crucible goes inside this cylinder furnace, which is heated up to 750 Celsius. And what they look for is whether that specimen has lost the mass after a period of time. And it actually looks also to see whether there's any flames that come out of that cylinder. And it also looks to see whether the increase in terms of the temperature inside that cylinder goes up or not. So those are the 3 things that looks after. And the final one at the end, that's actually measuring the powder in its raw form. So those 2 are cured, that's actually looking at the raw base powder. So 50 grams usually gets put into this kind of calorimetric bomb chamber, which sounds a bit like a James Bond type of contraption. That gets immersed in water, it combusts, and then the heat increases the temperature of the water, and that determines the calorific value. So that's the nitty-gritty of what all those tests look for. So essentially the results and average across those tests give you the final classification. So when it comes to powder, this is where you've got some grey areas in the market. If it's applied properly to industry recommended guidelines, it should give you A2 S1D0, which is permissible under Part B regs, okay? That's up to an average maximum of 110 microns, which is something we'll talk about later, no doubt. Now this is okay. For a lot of people, this is fine, they're happy with it, but then you've got some people out in the marketplace who are clamoring on the A1 bandwagon. They said, okay, well, that's A2, can we get A1? Is that feasible in powder? That's a question we always get asked. And technically, there's a lot of challenges, okay? So basically, to try and get an A1 rating on a proper coated aluminium, powder-coated surface, there's a few things that need to happen. So in that testing, that calorific value, so that final kind of test that we showed, the megajoules per kilo has to dip below 2. And typically, if powder's measured properly, it's anywhere between 2 to 3.5 megajoules per kilo. So that's the first hurdle that it's going to overcome. Second one, in that kind of combustibility test, you've got to have no sustained flaming coming out of that cylinder. That's important. And the temperature increase is going to be less than 30 degrees Celsius. Okay, so those are the 3 key criteria. So, powder is an organic coating. Okay, it comprises mostly of organic compounds within the formulation. To try and get an A1, realistically, what you've got to do is 2 things. you've got to try and reduce that organic content somehow. So you either do that through the formulation, or you do that by coating it thinner, much thinner, okay? So coating it thinner is not feasible because it goes below what the industry standards require you to do. And trying to take out a lot of the organic content in the formulation, that's essentially going to lead to something like this, which I think one of Dr. Stacey's projects from the 80s kind of looks like. This is where essentially you've got a breakdown of the polymers and you've got fast sort of reduction in terms of the aesthetic properties. So us trying to take a lot of pigment out of the formulation or the resin, it's difficult. And typically powder will contain anywhere between 50 up towards 85, 90% organic content. So realistically, you have to get that down to probably below 20, even 10% to stand a chance of getting A1 if applied at the right thicknesses. So that's obviously not welcomed by anyone. You don't want to see that within a few years of your building. And you're then entering the territory of, right, you're going to have to recoat or replace. So none of those are particularly appealing to any building owner. Now, before that harmonized European standard kicked in, there used to be this thing called, a British standard called BS476, which was not a bad standard, but it had some flaws. But one of the main testing for that was spread of flame. Now, I mentioned earlier about spread of flame being measured, but it was not really measured in the European standard. It's only visually observed. Now, this testing actually is used for London Underground, still to this day. And it's basically where you fix a specimen and it's exposed to the flame, and it basically, you're trying to make sure that does not spread by more than 165 mil within 10 minutes. And when powder's tested, it doesn't go more than 50 millimeters. Okay, so this notion that powder can actually contribute to spread of flame, it's a myth. And this is one of the tests that prove it, but it's not a test which is in the current Part B regulations. Okay, so this is where potentially further revisions could be made. Now, I mentioned earlier about some myths in the marketplace, and the way we try and convert those myths is we try and give people facts. I think there's a lot of Chinese whispers out there in terms of what you can do, what's possible. But it's when you start drilling down into the detail, that's when you start to see, okay, actually this is how things work. So what we've looked at so far is EN 13501. So that's looking at the material in isolation. It's not looking at the material in a complete system. Okay, so if this allows me to do so, here we go. So this is another test. This is a full-scale test, which you can't use at the moment for relevant buildings over 18 meters, but this can be used for those buildings that sit between 11 to 18 meters. Okay, so this is essentially trying to replicate fire breaking out from a room and then affecting 2 floors above. And what you have is a wooden crib that gets lit up. It lasts for about 30 minutes, then they extinguish it, then they observe it for another 30 minutes to see whether there's any issues with regards to the integrity and any kind of flaming droplets too. And essentially what this is full-scale test. So this is looking at the whole cladding system. So the insulation, the plasterboard, fixings, everything that you want. So it's quite a good holistic way of looking to see how, when things are put together, how they actually behave. Because it's very difficult to try and discern that from individual tests. So this is a typical example of a build-up, which I think from a specifiers point of view, this is quite a crucial section, because what you want to be doing here is engaging with the subcontractors, the system suppliers, rather than specifying these blindly. Really start talking to people, because that's where things can go wrong. This is obviously the first hurdle. If you don't specify it correctly, that's when the problems tend to start. So that's the first hurdle to overcome. So what we've got here, we're going to now look to see how that setup there performs in this test. Okay. So we've kind of almost dissected the test to kind of key milestones. And what tends to happen, and what's quite general and quite common, is within the first 3-4 minutes, that's when the paint starts being removed from the aluminium. And that's quite a critical point, because once you got that organic content removed from the aluminium surface, you haven't really got any residual energy or any residual calorific value left on that aluminium to spread the flame any further. So within 3 minutes, potentially, you pretty much limit your risks of that flame spreading straight away. As the test progresses, essentially more of the aluminium tends to get consumed. This particular test, the peak of the flame reached 4 meters. But what I've got here, hopefully, if technology allows, is a short video just to see how the system performs. So this may not work. We'll see. We'll give it a go. Yeah, it's a section. There's a time that it's quite a long wait. But there's a section coming up where you essentially it gets extinguished, and it gets extinguished in literally sort of 30 seconds. So potentially, if that system building was used on any given building, fire crews tackle it at source relatively quickly, and residents within the building can safely evacuate it. So yeah, we'll wait until that's milling away, because I think it's going to kick in for the next sort of 30 seconds. I might have to talk a bit more. But the key thing is, imagine that's a window and the fire's breaking out. Essentially what that flame is trying to do, it's trying to hunt for oxygen, okay? So as soon as it comes out, that's what it's doing. The best place for oxygen is usually in the cladding zone, okay? So particularly those narrow cavities. So essentially what you want to be doing there is making sure the cavity depths are right, the fire breaks are right, because if they're not right, you're going to get a chimney effect, and that's where you're going to get the spread of flame. It's not going to be the surface finish which will govern how well or how robust that is to surface spread of flame. Okay, whether that's powder, whether that's anodized, and here we have the guy finally coming round to it. So really, you want to make sure that it's all specified correctly. So you'll see how quickly this starts to get extinguished. We can stop it there. So that gives you an idea. So that was that system. If it's supplied correctly, you tend to have less issues, okay? So that's obviously looking at powder in isolation. We obviously don't just compete against other powder companies, we compete against things like anodizing, particularly in this city where it's quite prevalent. We also compete against pre-coat liquid. And the interesting thing about anodizing and pre-coat liquid, they're both rated A1 in most cases, okay? Although pre-coat, depending on the system configuration, can be in A2. But this is where the market's thinking, okay, we've got A2, but can we get it A1? And that's from an insurance point of view, from a mortgage lender point of view, they're quite risk averse, so that's where they tend to rely and lean more towards that, and maybe put premiums up for anything that doesn't achieve A1. And that causes quite a bit of issues as it goes down the supply chain. So what we've got here is almost a tailor the tape scenario, where we basically dissected an 8414 test for powder, the one that you just seen, for anodizing and for pre-coat. And rather than just me talking and giving you words on a screen, we've got pictures, which everybody loves pictures. So this hopefully will show it off to its best. So we've got 3 side by side. This is after the test, after 60 minutes. Hopefully the middle one, yeah, the angle of the sun is not helping, but hopefully you can see. Got anodized aluminium and pre-coat there. But essentially the level of impact in terms of what's been consumed, it's relatively comparative, okay? The fundamental thing is that none of those 3 systems have been compromised in any way, shape or form. That's the most critical thing. That's what happens to the panels. If we then strip it back like an onion and we start looking to see what happens to the insulation, again, it's a case of spot the difference. You know, you got partial charring, which is to be expected after a test like this. But again, fundamentally, none of those 3 are compromised in any way, shape or form. And if you strip it back 1 layer further and go into the membranes, again, it's rather non-discernible in terms of what differences you actually see. So this is the visuals, okay? But obviously, in that full cladding test, you've got thermocouples which are installed, both exterior and interior. So you can actually see what the temperature recordings are. So this is where it starts to get more interesting, and this is probably where a lot of people don't deep dive into this sort of detail, and they just look at the headline numbers. But the key thing here is to look at 2 numbers, or 3 numbers actually. the start temperature, the peak temperature, the plasterboard, and the peak temperature, which is the third one here. So this is the PPC system, which you just saw. Test took place in January, so it's a nice cool 7 degrees Celsius at the start of the test. But what you see there, the plasterboard is measuring at 14 degrees. So that differential, which is 7 degrees Celsius, that's potentially the worst case scenario for a person living 2 floors above. So 7-degree uplift, okay? The peak temperature doesn't reach 400. The anodizing, again, you've got a 13-degree difference there. And the peak temperature, which is just 30 degrees more, but again, that's not going to harm anybody. And the pre-coats, 10-degree differential and a peak of almost 500. But again, this is where once you start drilling into the detail, you start thinking, okay, well, that's A1 and that's A2, but actually is it mitigating me? Is it giving me any risk? Is it basically giving me more assurances? And in reality, it's not always the case. And I'm going to be killed off soon, so I've got to end on one slide because these are the practical issues. We've obviously got the commercials which kick in from time to time. This is a nice little graph, but to be honest, it's one of those where powder will always give an advantage, but also from a design perspective, the other two really narrow your choices down in terms of having boxes which people don't want. But I guess the key message really, and to end on, is that second one here. You specify the system correctly, if you configure it correctly and you get it installed properly, you've got safe cladding as long as it's A2 and A1. Okay, that's the critical message. One of those 3 things not done correctly, you've got a problem irrespective of what finish you have. And that's ultimately what governs fire safety. So yeah, I think I'm out of time. So thank you for your time and look forward to your questions. Thank you.